So this is a atom test part 4. This won't take very long to go through, but let's talk about what we should have done on this. So the first thing I'm going to do is copy these two arrows, because I'm going to need to use those in the diagram down below. What we're going to do is put the electrons in the proper place for phosphorus. So it says right here, phosphorus. All right, so phosphorus. So to find phosphorus, I go to the periodic table, and it's element number 15. So that means it has 15 protons, and assuming there's no charge, it has 15 electrons. If it had a charge, the charge would be -3, and it would tend to gain 3 electrons, but it doesn't say that, so we're going to assume that the electrons equal the protons. So then I need to put in 15 arrows. So by copying the way I did, let's see here, I copied them. I have to recopy because I'm not sure what happened with my copy and paste there, so copy those. And then put that in. So there's 1s, there's 2s has 2. The 2p, normally you'd put these in one at a time, but since I know that's going to be full, I went ahead and put them in pairs. Now, however, I'm up to 12 electrons. So 2, 4, 6, 8, 10, 12. And phosphorus had 15. So I need to put single arrows in here. And the way I got the single arrow was to just copy one of these right there and paste it in. So that was what I wanted in the boxes. That's the orbital diagram for phosphorus. Now we're going to write the complete electron configuration for phosphorus. So what I'm going to do is write it out and then make it look good. So 1s has 2 electrons in it. You can see right here. The 2s has 2 electrons in it. The 2p has 6 electrons. See, 2, 4, 6. The 3s has 2 and the 3p has 3. So 3s with 2 and a 3p with 3. And then to make it look good, if you highlight this while you're holding the control button down on the Chromebook, it's a command button on the keyboards in the classroom. So the control button, and then hit the period while you're holding a control button down, and that makes these numbers go up and down. So control period is a superscript. So that's your complete electron configuration. Now the outer shell for phosphorus would include only the highest energy level. So that would be the 3s and the 3p. Notice that there's a 3 here and a 3 here. So it's the highest, all parts of the highest energy level means be sure you get both the 3s and the 3p. So it would look like that. So what I did to make it easy to do is I just copied the outer shell and pasted it down here. On retake there may be a bigger element, so if sometimes you might have a 4s and then a 3d and then a 4p. The 4s and the 4p would be the outer shell, but not the 3d. All right, last two questions. What element is this? So you have to add up the electrons for that. So argon, writing this symbol right here, means the same number of electrons that argon has. So argon has 18 electrons. So that's 18. Then 2 more makes 20. 10 more makes 30. And then 5 more makes 35. So there would be 18, 20, 30, 35. Go over here and see what element 35 is, and that's bromine. So the answer to that was, and use the same kind of logic down here. This is xenon, 6s2, so you go see how many electrons xenon has. It's 54. Plus the 6s2, so 54, 55, 56, the element is barium. All right, and that is part 4 of the test.